Hi, so welcome to the video lecture on standard normal distribution. We'll start by talking about continuous distributions in general, because the normal distribution is a continuous distribution. So the first thing I need to tell you about continuous distributions is that they have infinitely many possible values that the random variable could take on. And what that means is any number could go out theoretically to infinitely many decimal places. So there are infinitely many possible values. So that means we can't list them all in a table like we did with discrete distributions. Instead, we need to either give the probabilities in a formula or a graph. Since there are infinitely many possible values that the random variable could take on, the probability that the random variable equals one particular value, like 0 or 1 or whatever you want to pick, 0.25382, that probability is going to be really, really small, practically zero. An analogy I like to use is if you imagine for all practical purposes, there are infinitely many grains of sand on the planet. So if I took a grain of sand and hid it somewhere on a beach, somewhere on planet Earth, and asked you to go pick up a grain of sand somewhere on planet Earth, the probability that you would pick up the exact one I left is 1 out of infinity, or practically zero. So that's basically what's going on here. So instead, we don't talk about the probability that the random variable equals a value. We talk about the probability that the random variable is less than some number, greater than some number, between two particular values. So now let's talk about the normal distribution. So there are two reasons we study the normal distribution. In the real world, a lot of things fit the normal distribution. Things like heights of people or IQ scores, a lot of things like that. The other reason is it's the basis for much of what we do in the second half of the course. So make sure you know this stuff before we move on, because it comes up much later, comes up a lot later in the course. So one thing I will tell you about the normal distribution is that it's symmetric. So you see, you could fold it in the middle, and it's the same on both sides. It's got just one peak. If it's got two peaks, then that would be called bimodal distribution, but normal curve is always single peaked. In the very middle is mu, and mu always corresponds to the highest point. And it also has a standard deviation. Mu can be any value, negative infinity to infinity. Sigma can be any value as long as it's above 0. So it can't be equal to 0, otherwise we don't have a random variable. And it can't be negative. So that's the normal distribution. That's the general normal distribution, where mu can be anything and sigma can be any value greater than 0. Now, this is a particular normal distribution, the standard normal distribution. It's the normal distribution with a mean of 0 and a standard deviation of 1. So mu equals 0, sigma equals 1. So anytime you see a problem with mu equals 0 and sigma equals 1, you know that's the standard normal distribution. And vice versa, anytime they talk about the standard normal distribution, that's the one with mu of 0 and sigma of 1. And anytime we're using the standard normal random variable, that's going to be z. Otherwise, we use x. Okay, so again, anytime you see z, that automatically means standard normal. And anytime you have standard normal, you're going to use z. Okay. All right. So the standard normal distribution looks just like one of the other normal distributions, except because the mean is 0, 0's going to be in the middle. We usually draw 3 standard deviations on each side. So -3, -2, -1, 0, 1, 2, 3. But the z-values really go out farther than that, from -infinity to +infinity. It never touches the axis. So it's, if you remember from algebra, it's an asymptote. All right. The area underneath the curve is 1, or 100%. So there's this correspondence between area under the curve and probability. So for example, looking back here, if I wanted to find the probability that z is between -1 and 0, we would shade this area between -1 and 0, and the area under the curve between -1 and 0 would be the normal probability. So there are umpteen ways you can find standard normal probabilities, but StatCrunch is really nice tool, and it's by far the easiest. So please don't go rogue and use some other tool. This is the easiest. All right, so first example. Let's find the probability that z is between -1 and 1. So remember, for continuous distributions, it doesn't matter if we say less than or equal to, because the equal to, the probability z equals to a particular value is 0. So it doesn't matter less than or equal to, greater than or equal to. All right, so if we look at a sketch here, you can see we have a shaded area between -1 and 1. That's going to correspond to the to our probability. Let me show you how to find this probability in StatCrunch. I'm going to escape out of here. And now, looking at our course website in MyStatLab, just like we did last week, we're going to go to StatCrunch, and we're going to visit the StatCrunch website, open StatCrunch, and then if we go to Stat, Calculators, pick Normal. Okay, so that pulls up this normal distribution calculator. You're going to love how easy this is. So there's 2 choices at the top. There's Standard and Between. So be sure and pay attention to which one of these you want to use. The probability that we're being asked for here is between. So you see where it says mean of 0 and a standard deviation of 1. We're working with the standard normal, so we want to keep that 0 and 1. And we actually don't have to change anything here, but if we wanted to, we could change that, make that -1 inside the parentheses, and then 1. Now it says it's x in between there. It says probability -1 less than or equal to x less than or equal to 1. This doesn't know the difference between x and z, but that's still not going to change your answer. Make sure you're using z whenever mean is 0 and standard deviation is 1. So once you type in your values, click compute, and then just to the right, you'll see that the area is 0.6827. Okay, and I think it's easy to see when you look at the normal curve. 0.6826. It looks like this is believable that 68% of this of the area is shaded here. Okay, so that looks like it's about 68%. So just like we did last time, I'm going to want you to copy and then follow the directions to copy your output into Word for your homework. All right, so back to the PowerPoint. So this is all you need to do for this problem. To find the probability that z is between -1 and 1, go to StatCrunch, type in your values, and you get a 0.6826. Okay? Now on your homework, I don't want you to assume that I can just look at this output and determine what it is. I can, but I want to see that you know what you're giving me. Okay, so tell me probability is 0.6826. Another thing I want to tell you about this is, do you remember the empirical rule said that if a data set follows a bell-shaped curve, about 68% of the data is going to be within one standard deviation. So in other words, one standard deviation below and one standard deviation above. Well, this is where that comes from. It comes from the normal probability. And this is exactly why your data needed to follow a bell-shaped curve in order for that to be valid. You can probably imagine if you put -2 and 2 in for your boundaries, you'd get about 95%. And if you put -3 and 3 in, you'd get almost all of it, or 99.7%. All right, so for the second example, we want to find the probability that z is less than -2.85. All right, so going back over to StatCrunch. This time we're going to pick standard because we don't want between. We want the probability that z is, we said less than 2.85? Yeah, less than -2.85. So for the under standard, we're going to leave the mean at 0, standard deviation at 1. Here, where it says less than or equal to, if they're asking for a greater than in the problem, we want to change that to greater than or equal to. They're not here, so we'll just leave it as less than or equal to. Hit -2.85 and compute, and it gives you the answer as 0.0022. And the shaded area is a little tiny area, so that makes sense that it's less than 0.00, or that it's a small area, 0.002. That shows you the area shaded to the left of -2.85, which would be down close to -3. All right, and according to the rare event rule, it would be rare that that z would be less than -2.85 because that probability is small. And now one more example. So one more example real quick. If we wanted to do the probability z greater than -1.24, we would just go back to StatCrunch, change the less than or equal to greater than or equal to, and then enter -1.24 and compute, and we'd get an answer of 0.8925. All right, so that's it for the normal probabilities. Stay tuned for the inverse normal probabilities.